Hello everyone, I'm back with another video. Now I'm gonna talk about an undecidable problem, that is RE, which is recursively enumerable problems. Let us see the contents. Introduction to undecidable problems, definition of RE problems, explanation of undecidability, example of undecidable problems, characteristics of RE problems, the halting problem as an example, importance of undecidable problems, challenges in solving undecidable problems, applications of undecidable problems, conclusion and summary. Now let us look into Introduction to Undecidable Problems. An undecidable problem is one for which it is impossible to build a single algorithm that always leads to the correct decision. These problems pose significant challenges in computer science and theoretical computer science. Undecidable problems are often related to questions of whether a particular algorithm can solve a certain type of problem or whether a specific program will halt or run forever. These types of problems have been extensively studied in the field of theoretical computer science. Now let us see definition of RE problems. Definition: RE problems, also known as recursively enumerable problems, are those for which a program can list all the solutions if there are any. These problems are of great importance in the field of computer science and computational theory. Let us see key characteristics. This classification is pivotal in understanding the nature of computability. It allows us to explore the limitations and possibilities of computation and to study the boundaries of what can be computed by algorithms. Explanation of undecidability. Complex concept. The concept of undecidability involves showing the limit of algorithmic processes. It explores the idea that are certain problems for which no algorithm can determine a correct solution. Mathematical proof. Undecidability is demonstrated through robust mathematical theorems. These theorems provide rigorous proof that certain problems are undecidable, meaning that no algorithm can solve them in all cases. Now let us see example of an undecidable problem. There are two examples. One is halting problem, second is implication in computer science. Now let us see halting problem. The halting problem is a classic example of an undecidable problem in computer science. It asks whether a given program will eventually halt or run forever. Alan Turing proved that there is no general algorithm that can solve this problem. Now let us see implication in computer science. The existence of undecidable problems has far-reaching implication in computer science. It highlights the limitations of computation and has implications for program correctness, compiler design, and formal verification. Undecidability is a fundamental concept in theoretical computer science. Now let us see characteristics of RE problems. Varying complexity and patterns and structures. RE problems can range from relatively simple to highly complex. Some problems may have straightforward solutions, while others require more advanced techniques and strategies. They often involve the identification of patterns and structures within data. By recognizing recurring patterns and understanding the underlying structures, one can gain insights and solve RE problems more effectively. Now let us see the halting problem of as an example. Computability. The halting problem highlights the limitations of algorithmic computability. It demonstrates that there are certain problems for which no algorithm can determine whether a program will halt or run forever. Complex decision making. It showcases the challenges in devising algorithms for decision making. The halting problem poses a fundamental challenge in designing algorithms that can make correct decisions about program termination as it is undecidable in general. Now let us see the importance of undecidable problems. One is challenging boundaries. Second is research impact. Now let us see challenging boundaries. Undecidable problems push the boundaries of computational thinking and problem solving. They present complex challenges that require innovative approaches and creative thinking to tackle. Second is research impact. Undecidable problems fuel deep exploration and understanding of the theoretical aspects of computation. They inspire researchers to delve into the fundamental principles of computation and discover new insights. Now let us see challenges in solving undecidable problems. Algorithmic complexity. Undecidable problems often involve addressing problems with insignificant algorithmic complexity. This complexity can make it difficult to develop efficient algorithms to solve the problem, and can also make it challenging to even determine whether a solution exists. Intellectual endeavor. The challenge of solving undecidable problems inspires intellectual pursuit and innovation in computer science. Researchers and practitioners are driven to explore new approaches and techniques that can help addressing these challenging problems. Now let us see applications of undecidable problems. Theoretical computer science. Undecidable problems shape the theoretical foundations and computational boundaries of computer science. They provide insights into the limits of what can be computed and help define the scope of computational problems. Cryptography. Undecidable problems have applications in cryptanalysis and information security. They are used to analyze the security of cryptographic systems and access the vulnerability of encryption algorithms. Now let us conclude the PPT. Impact on computation. Undecidable problems profoundly shape the limits of computational processes. They highlight the existence of problems that cannot be solved by any algorithm or program, no matter how powerful or efficient. Research and innovation. Undecidable problems drive fundamental research and innovation in computer science. They inspire the development of new computational models, algorithms, and techniques to tackle challenging problems and expand the boundaries of what is computationally possible. Thank you.